Broadcast is now starting. All attendees are in listen-only mode.
Good morning, afternoon, and evening to our global audience today. Welcome to Device Authority's webinar with special guests, Pen Test Partners. My name is Rosa Lenders, and I am pleased to introduce our speakers for today, Mark Harrison and Rob Dobson. Mark has over 12 years of security experience. He has consulted to the largest banks in the world, helped customers respond to major cyber attacks, and orchestrated global red team attacks against highly sensitive organizations. Mark is also well known for speaking around the world, discussing topics from IoT to banking and automotive to marine security. Rob has over 25 years of experience with a wide range of expertise across cybersecurity, IoT, software as a service, semiconductors, and software engineering. He has been involved in several successful startups, including Synaptic, where he ran the software engineering team, developing audio software and IP for mobile phones. Rob helps customers architect and deploy IoT solutions with the security they require. We expect the webinar to last approximately an hour, and we hope you can stay until the end to hear about a couple offers available to help accelerate your upcoming IoT projects. You will be able to submit questions via the question window in the GoToWebinar control panel throughout the session. We will try answer as many questions as possible at the end of the webinar. A recording of the webinar will be made available tomorrow on the Device Authority website, and everyone who registered will be emailed the link. I shall now hand over to our speakers.
Thank you, Rosa. Thank you for that great introduction. So just before we start, I just wanted to touch on a few of the key objectives and outcomes we'd like to go through today. As you can see on this slide, there's myself at the bottom there on the left-hand side and Mark at the top left-hand side. So just as setting the scene, the first thing really we wanted to cover here is to go into some of the examples of IoT device hacks. And Mark will take you through a couple of those examples and go into the details of what happened and why they were vulnerable. The second thing really is around want to learn about some of the common security issues, and we'll touch on a few of those points through this presentation and webinar. And we'll give you an insight into some of the future vulnerabilities in hacking, where we see possible future attacks and what might happen in that space. And we're also going to give you an understanding of where can you go to get some of the security best guidelines and best practices. And then hopefully through this webinar you'll gain some understanding about how you can protect your IoT devices. So just before we sort of get into the details of some of the device hacks and before I pass over to Mark, I just wanted to touch on a few areas. And in this slide here it says the future of IoT. What does that mean? And actually this picture is quite a grim looking picture. I was showing what's called the IoT repot. And this was a virus that was recognized back in the late 2017 actually, and this worm spreads by exploiting vulnerabilities in IoT software and hardware, and actually it leverages at least sort of 9 vulnerabilities across a dozen or so devices. And those vulnerabilities include things like sort of local file inclusion, gaining access to sensitive data through an unauthenticated web interface, and also sort of remote command execution, amongst others. And really what I'm trying to show you here is this is some type of hacks that are going to come in the future, and this is one of those. And this is an evolutionary step forward beyond the traditional sort of Mirai type attacks. And I see this as like a toolkit of exploits that these types of viruses and worms can go and use to exploit the vulnerability on the various pieces of hardware. But the bottom line here is that attacks are becoming more sophisticated and more complex. Or could the future of IoT look something like this? A bit rosier. And what I'm showing here really is that connecting people and things is one area where is really driving benefit for people, improving people's health, lifestyle, or maybe connecting medical devices to the home, for example, or in the hospital. Improving business processes, so production optimization. Maybe I'm going to improve my maintenance schedules on my industrial machines, or drive out some cost in my manufacturing facility. New innovation and growth areas, so driving new business areas such as smart lighting, smart building controls, or perhaps even enabling next generation experiences, smart city parking, etc. I love the day when I can just roll up to a parking slot without having to drive around the city for at least half an hour. This is obviously a much better picture, but without security in mind and without thinking about security right from the outset, I think IoT is going to struggle to get off the ground in earnest. So I'm just going to pass over to Mark now, who's going to take you through some of the interesting products he's been working on at Pentest Partners.
That will require me to come off mute. Right. Yes. So we're going to start off with hello, everyone. I'm Mark Harrison, and we're going to start with looking at the Amazon Dot. Now, the interesting part here is, a lot of people got them, myself included. So I need to be careful what I say because it can hear me right now. And the general question is to people is, do they think Amazon Echo is Amazon Dot is secure? Now, because you can't reply or put your hands up that I can see, I'll give you a few seconds to think about whether it's secure or not and have your own answer. Now, the answer to that, if you don't mind changing the slide, is they are fairly secure in the way they're manufactured, and whilst there have been a few vulnerabilities found in them, they've all been remediated fairly quickly, which is obviously a sign of a good manufacturer. The challenge is what you use to operate the Dot. So, for instance, August came out with the smart door lock, which is a great idea. For those people who don't want to carry keys, they can ask their Dot to open the door for them. Unfortunately, it comes with a few questions, especially by the fact that the Dot does not have any kind of voice recognition, so it will listen to anybody. So if you're turning up to the door and you're shouting through the door, Alexa, open door, and she does so, that's not really very good, is it? My Alexa's talking to me. Right. So a few other things that weren't really considered when the Dot was released are, I think there's a next slide here. Yes, no, next slide. Great. So who in the audience wanted a doll's house when they were a child? I would put my hand up, but it wasn't really on my list of toys. Now, there's a young girl in America who decided she wanted this particular doll's house. But she, when she asked her dad for it for Christmas, he said no. Birthday, no. She wasn't getting her doll's house, so she decided to use her common sense. And what she did was she spoke to her Amazon Dot. Now I'm going to unplug mine when I do this. And she said, Alexa, buy doll's house. And guess what? Alexa went off, bought her the said doll's house, which is a few £100s, and a few days later arrived at the door. Dad was quite impressed with the ingenuity of his daughter, so decided, well, you can keep the doll's house. And he then went and told a local news channel about what had happened. He also thought it was quite funny, so they then put it on the news and said to everybody on live news, well, this is what this girl did. She said to her Dot, Alexa, buy doll's house. What the reporter didn't realise was that now every single person who was watching their TV in earshot of their own Dot were also ordering their own doll's houses. So I think their doll's house did quite well, or the manufacturer did anyway. So that brings us on to Pentest Partners' favourite subject, which is the Wi-Fi Kettle. Now, obviously, the first point we'd like to discuss here is, why does anybody own a Wi-Fi Kettle? It saves you about, I don't know how long a kettle takes to boil nowadays, but I guess 10, 20 seconds. But you know, some people want to get the latest and greatest on the market, so they buy themselves a kettle. Unfortunately, this kettle is not a very secure kettle. But then you have to ask yourself, well, what can you actually do? If I was to hack into a kettle, what can I actually do? Well, surprisingly, quite a lot, because this kettle stores your wireless, so your SSID and your password. So if we were to get onto your kettle, which isn't too hard, we can then work out how it communicates, which is actually using Telnet. The password for the Telnet communication to the kettle is online, quite easily found. It's on the little. So let me step back a bit. Actually, the kettle itself, to make it Wi-Fi enabled, the manufacturer went to buy a little Wi-Fi module that they just basically soldered onto this kettle and added about £100 extra to their retail value. But this module has very limited security, mostly because it probably cost about 50 cents. And this Wi-Fi module stores the SSID and the key to your wireless home network, and it can't be wiped. So when we started communicating with the kettle via Telnet, we was able to say, oh, okay, great, we can communicate with said kettle, but unfortunately it's got a password. So it was like, all right, how are we going to get around this? So we Googled this little chip's manual online, and we found that the manual, because obviously this chip is used on lots of other devices, not just kettles, probably more useful ones, hopefully. And it had there in it the 6 zeros password. So all of a sudden we could connect to said kettle, which was great. And then we realized quite quickly the communication protocols between the kettle using Telnet were also on the manual. So they had one called 80 plus SSID. So we entered that into Telnet, and bam, straight away we got the SSID. That's not too exciting though. So we try another one, which was 80 plus key. Guess what? It's the Wi-Fi key. So straight away we've got the SSID and password to the kettle. Now, what can we then do? Well, our interesting theory was, well, a lot of people will get some of these Wi-Fi kettles and go, well, this is actually not very good, so I'm going to sell this kettle on eBay. Guess what? You sell a kettle on eBay, what are you going to have? You have the sender's address, and the fact they couldn't clear the Wi-Fi SSID or password means that you've got access to their Wi-Fi. Now, I'm not going to go into a lecture on what you can do when you're on somebody else's Wi-Fi, but it's quite a lot. It's quite scary. So we told the manufacturer, and their response is on this next slide. The hack requires specialist knowledge. That's not true. Absolutely not true. I could teach almost anybody to do it in about 10 minutes. And then they said, one would have to be very lucky to find a user with an iKettle. I mean, that surely can't be an acceptable response to an insecure IoT device. We don't sell enough of our products, so don't worry about it. Absolutely mental. So, so we was like, well, okay, let's see if that is the case. Let's prove it. So I don't know if anyone's heard of Wiggle. I use a different kind of Wiggle, which is a cycling shop. It's not that. Wiggle is for some people who have a hobby called, oh, what's it called? I can't remember now. But they set their phones up so that wherever they go in the world, it will scan for SSIDs and record where they've been seen. And then when it's in Wi-Fi or 4G range, it will upload it up to a site called wiggle.net. So then for users like myself, I can go, well, I want to search for particular SSIDs and where they've been seen. Luckily for us, all of the kettles use the exact same SSID, which is bad. If you think about your home routers, it will say Mark 12345. It will have a unique number, or you can change it yourself. All of these kettles have the exact same SSID, which means that we can geolocate them. And these are the ones that we plotted and found in London. Interestingly, so far, for all the talks I've done, I actually spoke to about 3 of these owners, which is great fun. So all of a sudden, you know, we can find these kettles, and you know, we can get into them. But the question is, well, what can we actually do once we get them? If we pop onto the next slide, so this is the point where we're on your.
Just before going on to that, Mark, so the basic premise there for getting onto the kettle was all about, you know, getting access via telnet and then digging into what chips on board and then going online and figuring out what the default passwords are. Is that right?
Yeah. It's just basically using old insecure technology, and they should give the user ability to change things.
Yeah.
And they're just not, or at least wipe them. If you're gonna store information like Wi-Fi keys, you should be able to wipe that before you sell it.
Sure. Okay.
So where IoT gets odd, I don't know if anybody's heard of my friend Kayla. Kayla is an interactive kids doll, which I think is actually quite a good idea. Certainly much more of a better idea than the kettle, which is a terrible idea. One of my colleagues was walking through around Toys R Us when Toys R Us still existed, and found Kayla, and she was professing to be internet safe and kid friendly. Well, our company is a company full of hackers, so when we see those kind of words, we think we're going to see whether you're telling the truth or not. So we bought a few Kaylas and we sat down to see what we could do with them. It's interesting. Basically, what Kayla does is a kid, or not kid, depending on what you want to do with Kayla, will speak to Kayla and say, "Hi Kayla, how are you? You know, what is the weather?" And Kayla will log into the internet and she'll come back with a logical answer. You know, it could be, what's the capital of Germany? You know, it's intelligent things here where it can actually be quite educational. So I think that's quite a good idea. Unfortunately, it's not been manufactured very securely. So when we decided, can we make her swear, this is what happened. On the next slide, please. So, and this is annoying actually, because typically I can, in a live demonstration, I can get Kayla, who is sat next to me here, and I can get her to do this part of the presentation. But I'm not sure how that's going to work today. So I'm not going to put on Kayla's voice because I'm going to sound very silly. So in essence, Kayla does not have a Bluetooth pin. So it means that anyone can connect to her easily. It's just, there's zero security there. Also, we found that it uses the Wiki API. We found that we could add swear words to her question database. We found that there was a database of words that she can't say, but it was a local database. So we found by decompiling the app, we could gain access to that and change it. We found a Wikipedia API, which we could intercept and modify. So in essence, Kayla was not very well manufactured, and anyone could log into Kayla and listen to what people were saying around Kayla, which is terrible. So not only can we make a kid's doll swear, we can also listen to what people were saying who are around Kayla, which is a bit freaky, especially if it's your man who is talking to Kayla. So we had a challenge of really getting the manufacturer of this product to listen to us and understand our problems, because let's face it, a lot of IoT manufacturers, especially when Kayla came out, weren't interested in security. Their idea was to be first to market, first internet-enabled doll, the first internet-enabled kettle. It didn't matter because there's plenty of people out there who were just willing to spend an extra £100 just to get the latest product. So we on the next slide, I think it shows when we managed to speak to BBC, because over the years we've published quite a few new vulnerabilities. We have relationships with various different broadcasters, and the BBC agreed to push this for us. So we got them to get in touch with the manufacturer, and I think in the end they came back and they said that they'll do a fix. I think a couple of slides down it shows we'll be issuing an update to the mobile app to fix the issues. And this is great. This is what we want. You know, we do want to publish the research that we do, but we only really want to publish it once a patch has been issued, because you know we're not in the game of making the internet more insecure. We're in the game of fixing things. And yeah, our day-to-day is working for banks and for car companies, and they ask us to test them, find the issues, and they fix it. And that's exactly the same. The things that we do in our spare time, like testing Kayla and various other devices, the idea is us find the issues, tell the manufacturers, they fix it, we publish it, get the kudos, and everyone's happy. So they fixed it. Unfortunately, on the next slide, we find that they used a static encryption key, which is stored in the mobile application. Now, for anyone who knows anything about mobile applications, they will know that it is not very hard to decompile a mobile application, gain that encryption key, and yeah, it's just not very good practice whatsoever. So so this kind of went dead for a while. I think they fixed some more things, but it was still very insecure, and we kind of left it, forgot about it. So a year later, you can see that the BEUC, so on the next slide, they picked this up, and they said this is terrible. You know, this is essentially a covert listening device. And so they publish it around all their different peered organizations in different countries. And in the end, this is the best part, Germany picked it up and they said, well, this is illegal in our country because Kayla is acting as a covert listening device. If anyone can log into that doll and remotely listen to her, then yeah, that's bugging. So Kayla now comes with a 20,000 euro fine if you're caught with her in Germany. The great part of this is they actually sent out a letter to everyone who owned a Kayla, with instructions of how to destroy your Kayla. And the two options were, and there's actually images of showing how people had to do this. One was a hammer, and the other was fire. So
well, that's,
yeah,
that's quite extreme, Mark. So just let me get this straight. So the fix was basically to use a fixed static key. Was that a generic key for all the Kayla devices, or was it a unique key?
I can't remember actually. I think it was the same key. But the fact it was static didn't really matter to us because you guess it regardless.
Yeah, sure. And then obviously it wasn't stored securely, which is obviously another bad thing to do.
Correct. Yeah, so I assume most of the people in this presentation will know about at least the first 2 points here. And the third point here is, have I been pawned? For those who don't know about this website, it's really interesting one to use for yourself or for your friends and family, run by Troy Hunt. You put your email addresses in there and it tells you if your accounts have been compromised at some point by different things you signed up for. Really interesting, worth using. And my final point here is, we pick on the kettle a lot because it's an extreme fact, but just consider what internet-enabled devices you need to buy. I'm doing it now myself, renovating my house. There's some of the best devices, the washing machines, the fridges, they come internet-enabled. You're thinking this is crazy. Like, I can't buy a good device without it being internet enabled. And then you got to, if you're going to buy one of these devices, you got to look at the terms and conditions and the privacy statements that come with them, and understand what data they take, where they put it. In essence, if you don't need them to be connected to the internet, don't allow them to be. I think that's it from me.
Thanks, Mark. Perfect. Thank you.
No worries.
So just kind of sort of full circle on some of the things that Mark was talking about, actually. And I just wanted to sort of highlight, so what are some of the most common issues in IoT devices? And we've got a few points just to talk through here, really. And one of those, the first one there is really around weak credentials, and Mark touched on a few of those there. So fixed static credentials and keys. You know, where the devices are using a generic key across all their deployed products. Not ideal. Someone can get access to those products and steal the key. Also Mark touched on weak credentials, i.e. passwords. I've lost count on the number of products that we've seen which use default passwords, you know, admin, username, password, CCTV, routers, gateway, terminals, you name it. They typically all suffer from the same problem. Again, not a good idea to shut your product out at all without some way of changing them. Firmware upgrades. Also, we see products that are shipped out of the door with without an ability to upgrade the firmware in the field post-deployment. So, you know, let's be honest, no product's ever going to be 100% secure. So you need to provide a mechanism to be able to patch those devices in the field, so you can at least, you know, fix those issues as they come up and crop up. Otherwise, it can become very expensive. Maybe you have to ditch the product, or there's a man in a van that has to go around and update the firmware locally, which is quite expensive. The third thing on there is really around key storage and management, and kind of touched on that in the Kayla doll example. You know, if you're going to use keys, then probably a good way to use them is to put them in somewhere secure on your end device and make sure they're kept safe. So somebody, if they do break in, they can't access those keys, and they're pointless storing them in clear text on your device, because someone can just read them out and use them. And then, you know, one of the fundamental things I see in IoT is a lack of identity and trust at the edge. And what do I mean by that? Well, you know, how can I trust my IoT devices outside the perimeter? And a lot of devices are shipped out the door with, you know, pretty much no identity. You know, and how do you manage the security around those devices without identity at the edge is a real challenge. Not secure by design is the next one here. Really is, you know, security is generally an afterthought of most products, and we see examples of customer product whereby security hasn't been thought through, and you come to a problem and a vulnerability, and it goes back to things like the firmware upgrade example. If I can't patch those products, then it's not secure by design. I can't do anything about it. What do I do? And it's expensive then for the customer to go and fix it. So the next thing really on here is secure boot. So what do I do about protecting my firmware? How can I ensure the firmware of my product, when it boots, is its integrity is correct? How do I know that hasn't been tampered with? Secure boot. I mean, I think that's a key part of the problem here as well. And I mean, a lot of products are coming out now with secure boot in mind. There's still an awful lot that don't. And the last thing there really is around data trust and privacy for IoT. You know, we've only seen recently around Facebook. I know it's not really an IoT product, but data privacy is a really important factor here, especially when you consider things like GDPR compliance or HIPAA compliance for healthcare type products, or indeed even, you know, moving on to some industrial applications and beyond. You know, if you need to protect the data and be able to trust the data feed into your IoT platforms, you need to take security seriously. And yeah, we don't see that as much as we'd like to today in the IoT products. And for me, all of these things boil down to a couple of key factors. And IoT scale is the key driving one there, right? So the premise of I need to ship products, this large volume, ship them and sell them quick sort of thing. Well, you know, without having automation and efficiency there to manage security at IoT scale, then you can't do the security you want. You can't apply the same security as you would in the enterprise. And that's where the real challenges are, and the real focus needs to be, is how do I operationalize security for IoT? And that's what I see as one of the fundamental challenges there. So what next? Future vulnerabilities. Well, we've seen a lot of DDoS style attacks over the last so many years, and I can only see those getting larger scale DDoS. For me, more devices equals larger DDoS and more often, and amplified DDoS as well. So if we don't take security seriously on IoT devices, then it becomes more and more of a problem. Hackers are continuing to get smarter. As we touched on previously, the IoT repot is coming, and I'm sure others will evolve as well to become even smarter, to be able to go out there and hack your devices and compromise your devices through the vulnerabilities that it will exploit. There's another thing here I put down is dark web, hack as a service. I've made that up, by the way. It's HAS, a bit like SaaS, but HAS. And the reason I said that is that we see examples whereby perhaps you can order up a service from somebody on the dark web to go and attack a competitor's website or attack some known products out there to use in some kind of instrumented DDoS style of attack. Attacks on a consumer, you probably buy a product with no security, somebody takes control of it, it becomes useless. Or in the Kayla doll example, somebody managed to get onto the Kayla doll and swear at your young daughter or young son. Not a good idea. Not something I want to think about anyway. And the last thing there is really attacks on medium enterprise that haven't considered security. So we see obviously those tier 1 type customers obviously have a security policy, have a procedure in place to at least look at security and build out their security for IoT products. But I think the SMEs have still got some work to do there, and also the same for some of the larger value goods. So things like automotive, I think there's still a requirement and still a push there needed to get security level needed. And I give you a personal example whereby recently I bought a second-hand car. It was a year old. And on that car, it's got location-based services. And unless you turn those location-based services off, if you drive that car to your home and you don't turn off the GPS on it, the previous owner can download their app, go into the app, find out where your car is, and then use their second key fob or third key fob to get in there on the train, come down and just drive the car away. I think that's another area to explore further. So doom and gloom aside, what can we do about it? Well, there are a number of best practices and organisations out here, and I've just picked on this one here. It's actually called the Internet of Things Security Foundation, who have been working with all the industry experts to build out, if you like, some areas to think about for securing your IoT products. And there's a number of working groups here, and I'll just touch on one or two of them. The WG1 is basically a self-certification scheme. It's just building out a framework or compliance framework. So product manufacturers can take this framework and it's basically like a checklist or a matrix to show and demonstrate your conformance to a certain level of security. And then WG2 has if you like, a short checklist of some of the best practices you can adopt on your product. And the final one there around WG7 I'm going to touch on is around trust marks. So being able to, if you like, put a mark on your product to say, hey, I conform to best practices of security, the ITSF, as an example. And the next thing really I just want to touch on is secure by design. So only last week, or I think it's 2 weeks ago now actually, the DCMS, so the Department for Digital Culture, Media and Sport, released a paper which is basically a code of practice paper for IoT consumer products. And some of the items they're talking about in here have synergies with what we talk about today, and actually for IoT products are very relevant. If you are going to produce that internet-enabled kettle, I'd question why you want to do that in the first place, personally, then maybe there's some things in here you want to take away. So things like no default passwords, don't use default passwords on your end products. Implement a vulnerability disclosure policy. So if things do go wrong, and they will go wrong, what do I do about it? I need to communicate that and have a policy of how to manage that. Keep software updated. We've touched on that a few times today. So being able to update the firmware remotely and update and patch it if vulnerabilities do become relevant, then that's something you need to do. Secure your credentials and sensitive data on your product securely. And you know, we touched on that previously in the Kayla doll example as well. And communicate securely. So if you're transmitting data over the internet or over a network, you want to encrypt the data, make sure you've got privacy for that data. And you want to minimize some of those exposed attack surfaces as well. So things like, you know, Mark touched on telnet to one of the devices. Perhaps you want to turn off the telnet or close out the ports to those products before the products get shipped out the door. Don't leave them open. And there are a number of other things in here which they recommend, yeah, and you can see those on the right hand side through steps 7 to 13. I would also like to just bring you to one of the blogs that we produced, I think it was last week, which touches on a number of these elements as well, but goes into a little bit more detail how you can solve some of those problems with our actually Keyscaler solution. So just before we end this session, it would be wrong of me not to at least touch on Keyscaler as a solution, obviously from Device Authority. And this slide here really talks about what we call the Enterprise IoT Security Solution Blueprint. A bit of a mouthful, but I'm going to talk through what it means. And you can see here there's a number of elements. So you've got the IoT devices on the left, data center in the middle, and enterprise to the right. And we see the Keyscaler solution, which is our IoT security platform, as the glue to glue all of these components together, so you can reach out from the enterprise into to connecting your IoT devices securely and managing those devices. So on the left, you've got step 1, which is provisioning your root keys in production. So how do I get those keys on board those devices in the production? And how do I whitelist those keys into a known service? How do I onboard these devices to a service application? You know, how do I do that securely? And actually, Intel basically recently set up a service called Secure Device Onboarding, and actually we're part of that whole partner process, and actually instrumental to delivering keys and credentials beyond like the day zero onboarding process. And beyond that, looking at step 3, you've got how you manage and provision credentials to those IoT devices once you have them authorized into your platform. And this is where Keyscaler comes into real effect here, is really building out a strong, robust security posture, being able to update the keys, being able to manage the certificates in an automated way to solve that whole challenge of IoT, which is scale, and being able to plug in the appropriate security solution for the appropriate IoT platform. And we're calling this our IoT IAM platform, by the way. And the final piece of the puzzle is, well, how do I interface my well understood enterprise level security functions, such as HSMs on the back end, to my IoT solution? Well, our Keyscaler solution, we've got connectors which allow us to connect to HSM, so you can store all your sensitive crypto material. But at the same time, be confident you can reach out and you can deploy your IoT solution and your products outside of the perimeter without ever having to touch those with human hands. So really, that's kind of it in a nutshell. But the 3 key points there, I'll just touch on the final 3 things. Is the device trust is what we're bringing here as well. So identity integrity, the data trust, so how you secure your data from the edge to your back-end platform, and then operationalizing that trust at IoT scale. And that's one of the fundamental challenges we're solving with the with the Keyscaler platform. So I think that's pretty much it from myself and Mark. Apart from obviously, if you want to contact us, you can contact us on the details on the slide we have in front of us. And I'm going to hand over back to Rosa.
Thank you, Rob, and also Mark. Some great content there. Really good to hear about some of the real world examples. I'm going to open up for Q&A now. If you haven't submitted your question already, please do so via the question window on the control panel. Right, Rob, I've had a question in for you. So you've mentioned weak credentials. How do you manage tens of thousands of passwords on IoT devices?
Yeah, that's a really good question, Rosa. And well, it really needs a sort of centralized management process and a security platform so you can manage all of your passwords remotely in one centralized location. And to do that successfully, you need to have a strong identity at the edge and, if you like, a mechanism to onboard your devices and automate the process for security and renew all those passwords at large scale without ever having to touch them in a manual way, right? So the last thing you want is to have 10,000 devices and somebody has to go in, log in and change the passwords. It will just never work.
Great, thanks, Rob. Mark, if you're still there, I've got a question for you as well.
Yes, still here.
So someone's just picked up on the mention of cars and connected car technology, and they're just wondering more about basically the automotive industry and whether it needs to improve its security.
Absolutely. I mean, there's been 3 quite well-known hacks recently. The Jeep hack, which was hacked via the infotainment unit. So yeah, they were able to take control of everything, the engine, heating, audio, all remotely, which is a bit scary. There's a Leaf one. I can't remember too much about that one, but the Tesla attack was a really good one. It was done by the Cloudflare team. It's not something that we did ourselves. It wasn't remote, but they could start the car and drive it. And also, if there was to plant a Trojan for future, they could remotely DOS the car. Which is crazy, right? So you can really does the car. I mean, in fair play to Tesla, the brakes would still work, so that's good. I think the key to automotive security is good, strong, secure over-the-air patching. Without that, you're in trouble.
Yeah, I think you're right there, Mark. It's either that or you go back to having a car which doesn't have all the gizmos on board.
Yeah. But then you wouldn't sell any cars.
Yeah, that's true.
Okay, Rob, I've just had a question I think you can answer.
Okay.
Does Keyscaler handle devices that are not SDO enabled?
Yeah, and the answer to that is yes, it does handle devices that are not SDO enabled. So we have a couple of solutions which allow us to authenticate from the edge to Keyscaler, and that also allows us to securely onboard those devices in an automated way, and also then provision beyond that secure onboarding process credentials, keys, and manage crypto to basically IoT platforms if that's what you need to do as well. So yes, this is the answer to that one.
Great, thanks. I think we've got time for one more question for you, Mark. They're just wondering, what would your sort of main advice be for the device manufacturers, such as Kayla or iKettle, or any other consumer devices?
I mean, strangely, making them secure is firstly make themselves accessible. So make sure they've got a security at address. So make sure that when we find issues, they can receive those issues and they can respond to them. The worst case scenario for us when we find issues and the companies you can't get in contact with them. And all we can get in contact with is, say, a PR company or marketing person who's trying to block us. So all we want to do is help. But from the IoT manufacturing side of things, I think the manufacturers need to put their hands in their pocket maybe a little bit more and consider security. Yeah, I'll leave it there. I could go on forever.
Thank you, Mark, and also thanks, Rob. Any questions we've not been able to answer will be answered individually this week. We've now come to the end of the webinar. A big thank you to our speakers and also to our audience. Just a reminder that I hope you can join our next webinar, which is now scheduled for April 12th, and we'll have speakers from Intel and Komodo CA. If you have any further questions, please do not hesitate to contact us. There's some information on the screen now, and we hope to speak to you all soon. Bye.
Bye.
Bye-bye.